Okay, so this is question 12. An athlete associated, now we're doing question 12. An athletic association decided to host an athletic event. The following 12 male athletes were selected according to their personal best times for the season on a 100-meter sprint. So we're having 12 male athletes. So they're defined using these alphabets. In Northwest, there was an athlete A and B. In Gauteng, an athlete A, B, and C had their personal best times. And in Limpopo, we have A and B. In Mpumalanga, we have A, B, and C. In Free State, we have A and B athletes. So these are the 12 athletes that were selected according to their best times for the season. So no athlete had the same personal best times. There are 12 lanes next to each other in the stadium. So think of it as a track. So let's say this is a track. So remember that if this is a track, and then this is a lane of a track, right? Think of it as a 100-meter distance, and this is 1, this is 2, 3, 4, 5, 6, 7, lane number 7, lane number 8, lane number 9, and lane number 10, lane number 11, and lane number 12. So there are 12 lanes, so, and also 12 males. So please visualize. And then 12.1, if the 12 athletes are placed according to their personal best times from fastest to slowest in lane 1 to 2. So let's say, for an example, here in lane 1, so let's say, for an example, in lane 1, we have the fastest runner or athlete. Then as you go down, we go to the slower or the slow athletes, right? So yeah, just think of that. So if the athletes are placed according to your personal best times from fastest to slowest, from lane 1 to 12, independent of the province they represent. So you don't have to consider if they come from Northwest, Gauteng, Limpopo, Mpumalanga, or Free State. So just neglect the province. In how many ways can the athletes be placed, right? So if you only consider the best times, if you place these athletes according to the best times, and you say this athlete number 1, best time for a 100-meter race, for a 100-meter race, let's say, for an example, the athlete number 1 takes 10 seconds, athlete number 2 takes 11 seconds, athlete number 3 takes 11 seconds, 0.5, athlete number 4, 11.6, 11.7, this one, 11.8, 11.9, 11.10, 11.12, 11.14, 11.16, 11.18. So let's say you place these athletes according to their best times, and these are the examples of the times that I've stated, and you neglect the fact that they come from certain provinces which are different. So, and then I ask you, how many ways can you place these athletes? You can only place them once, because you only, the critical point here, the condition is you have to place them according to their best times, and the best time here above all is 10. So the rest the time goes slower, or you go from the highest to the lowest time as you go down. So for 12.1, you're only going to place the athletes one way. Fine. 12.2 says that the organizers of the event decide not to place the athlete according to their best times. So let's say, for example, you now no longer want to consider this, placing the athletes according to their best times, but the organizers change. They say, but to place each athlete's name in a container. So let's say you have a container, and then you're going to place the athlete's name, A, B, C, whatever the name is. You're going to place the name in a container and select an athlete for each lane randomly. So you're going to select these athletes randomly for each lane, from lane number 1 to lane number 12. Remember that the number of lanes is 12. The A athletes from Mpumalanga and the A athletes from Gauteng do not want to run next to each other. So let's say an athlete from Mpumalanga is here. So we need to consider that. How many ways can the 12 athlete be placed next to each other so that athlete A from Mpumalanga and athlete A from Gauteng do not run next to each other? So I want to know the number of ways at which these athletes are going to run. But we know that there's how many athletes? N is equal to 12. That is the number of athletes, right? And there's 2 athletes that will not run next to each other. So this represents 2 athletes. This represents the total number of athletes, right? And then we want these athletes not to run next to each other. So you're gonna say N, which is the total number of athletes, minus the 2 athletes, and then N minus 1 factorial. So this will mean that the athletes do not want. So the entire expression, this expression says that these 2 athletes will not run next to each other. Remember that N factorial is the total number of athletes. A 2 factorial, it is those 2 athletes that don't want to run next to each other. And then N minus 1 basically means that you do not, it's like saying if N is the last term, what is the previous term before N? It's N minus 1, right? So this is next to N, right? So it determines the position between N and the previous term, which is N minus 1. So hence this defines the previous term, which is N minus 1. So the entire expression says that the athletes do not want to run next to each other. So you're gonna say, instead of writing N factorial here, you're going to write the total, which is 12. So it's going to be 12 factorial minus the 2 athletes that don't want to run next to each other, and 12 minus 1 factorial. So the final answer for this problem is going to be 399,168,000. So this will be the answer that defines the placement of these athletes, taking note that there's 2 athletes that don't want to be placed next to each other, athlete A of Mpumalanga and athlete A of Gauteng. So 12.3, in how many ways can athletes be placed randomly next to each other if the 2 C athletes must run in the two outside lanes from lane 1. It's either, okay, the outside lanes, it's the first lane or the 12th lane. The A and B athlete must run alternatively. So remember that we have athletes A and B and C, and we are told that in how many ways can this athlete be placed such that the athlete C runs in the outside lane. So remember that this is lane number 1. If let's say athlete C runs here and another athlete C runs here, taking note that there's only 2 athletes C from the given question. So if athlete C runs here and another athlete C, let's say this is C1 and this is C2, because these are 2 C athletes, they are not identical from each other. So let's say they run from outside lane, so which means in between it's going to be what? It's going to be athlete B, athlete so athlete B and athlete A. So it's going to be, so athlete A and B will run randomly, like they'll just run, they'll be placed differently, right, between C1 and C2. So it's going to be A, B, and 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 A, right? So they're going to be placed differently. Either be placed like this, or if let's say this is C2 and then this is C1, right? So meaning instead of writing AB, it can be BA, 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 BA. So the number of ways that the middle athletes will be placed is two ways. They'll be placed either in this way or in this way, right? So we need to consider that. So our answer here, so what we need to do is, there's 2 ways to place the C's, right? Either this way or this way. 2 ways to place C's, and then multiply by, there's also 2 ways to place the A's and B's, either this way or this way, since they'll be placed randomly. So multiply by 2 times, and the consider the factorial of the middle athletes. So how many A's are here? So 1, 2, 3. So let me use a different color. So there's 1, 2. Let me use blue. 1, 2, 3, 4, 5, 6. So there's 6 A's. No. Considering that we have 12 number of male athletes minus the C's, which are 2, we remain with 10, right? So if you remain with 10, it means now that in this 10 there's a combination of athlete A and athlete B, right? So there's, that means now that if 10 represents athlete A and athlete B, it means athlete A, athletes of A are 5, athletes of B are 5. So these athletes will be placed differently, hence we put factorial. They'll be placed differently. So we're going to say 5 factorial multiplied by 5 factorial, right, times. So the placement of these athletes will be ones. So remember that it's going to be AB, 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 AB. So we're just going to multiply by 1, and the answer to this question is going to be 57600. 600. So this is going to be your answer for 12.3. So now 12.4. At the end of the event, a fun run is held where only 6 athletes are allowed to run if the 6 athletes are chosen randomly. Remember that we have athletes A, B, and C, and there are a total of 12 athletes, but for this fun run we only need 6 athletes. It can be A, B, or C, we don't really know. What is the probability that there will be only 1 athlete from Free State competing in the fun run? So remember that going to the number of athletes of Free State, there's only 2. So there's a possibility that it can be athlete A or athlete B, but not both. So only 1 athlete will be chosen from the Free State. So let's first find the probability of that. So for the Free State, we're gonna say out of those 2 athletes, only 1 is going to be chosen, right? So it's going to be the 2 athletes out of a possible 6 athletes. Remember that we want 6 athletes. So P is equals to, so remember the question says, what is the probability that there will be only 1 athlete from the Free State running? So the 2 represents those 2 athletes from the Free State multiplied by the factorial of 10. So it's going to be 10 times 9 times 8 times 7 times 6. So what does this mean? We are having a factorial of 12, but we are removing 2 of those athletes who are separated, and so these 2 athletes are from Free State, and we only want 1 athlete out of these 2. So we're going to remain with 10, and if we remain with 10 factorial, we only want 6 athletes to participate. Hence it's going to be 10 times 9 times 8 times 7 times 6, right? So we're going to divide that. So but before we divide, we have to multiply by the total number of athletes that are chosen, which is 6, right? Then we divide by the total factorial, which is 12, right? But this 12 is going to end at 6 contestants. So it's 12 times 11 times 10 times 9 times 8 times 7. Remember, we only want 6 remember we only want 6 contestants. So hence we're gonna end at 7. Now the probability of us choosing 1 contestant from Free State is going to be 6/11. So this is the final answer. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.